juniors, we are going to talk today about Algebra II Section 3.1, which deals with polynomials. Polynomials are expressions that contain numbers, operations, and variables. So when is an expression not a polynomial? Well, according to our definition, polynomials have to have real coefficients. In other words, no imaginary numbers can be involved in the coefficients, and whole exponents. Remember, whole numbers are 0, 1, 2, 3, and so on. No fractions, no decimals, and no negatives in the exponents. When we are dealing with polynomials, we want to have them in standard form. Standard form means that the largest exponent comes first, and the largest exponent is also called the degree of the polynomial. If a polynomial has a degree of 0, it's labeled as a constant polynomial. 1 is linear, 2 is quadratic, 3 is cubic, 4 is quartic, and 5 is quintic. Also among our polynomials, we're going to want to identify the leading coefficient. The leading coefficient is the first coefficient when my polynomial is written in standard form. In order to give the type of polynomial, you're also going to want to count how many terms the polynomial has. If it has one term, it's labeled a monomial, 2 terms a binomial, 3 terms a trinomial, and 4 or more a polynomial. Please note that this information is on pages 150 and 151 in your book, so as you're completing your assignment, you may want to use those pages as a reference. The first thing we're going to do with polynomials is decide if the function is a polynomial. If it is, we are going to write it in standard form, state the degree, the number of terms, the leading coefficient, and name the polynomial. So I'm going to do these exercises for you. Watch so that you understand how to do your assignment. Starting with letter A, is it a polynomial? First thing I would check is for any i's, imaginary numbers. Those don't occur. Then I would look at the exponents. My exponents are 4, 2, and this is actually 3x to the 0 power. So no negatives, no fractions. This is a polynomial. In standard form, my highest exponent should come first. It does. So this polynomial is actually already written in standard form, so I will simply rewrite it. The next question it asks is to state its degree. The degree is the largest exponent. In this case, the largest exponent is 4, so it's a 4th degree polynomial. Number of terms. This polynomial has 1, 2, 3 terms. Terms are separated by plus and minus signs, so you'll be able to count those pretty easily. The leading coefficient is the number in front of the first term, so this one has a leading coefficient as 1. Last, we're going to name the polynomial. It is a 4th degree polynomial with 3 terms, so we would call it a quartic trinomial. Letter B, checking to see if it's a polynomial. My coefficients are real numbers, my exponents are whole numbers, so there's no problem there. Standard form. This has an exponent of 2 and a y exponent of 1. It has the largest exponent, therefore it should be first. Sorry. So since there's 2 variables, what is the degree? Well, if there is more than one variable, to find the degree, we add the degree of each separate variable. So the x has an exponent of 2, the y has an exponent of 1, so this is a 3rd degree polynomial. It has 2 terms, and its leading coefficient is 4. Degree 3, 2 terms. If I named this, it would be a cubic binomial. Letter C, is it a polynomial? My coefficients are real numbers. However, I have an exponent that is not a whole number because it is negative. So this is not a polynomial, and I am done with that problem. Letter D. Exponents are fine. My coefficients are fine. No imaginary, no fractions. So this one is a polynomial. In standard form, my x cubed term should come first. My x squared term second. My x to the first term third. And my x to the 0 term last. What is the degree of this polynomial? My largest exponent is 3. How many terms does it have? It has 1, 2, 3, 4 terms. The leading coefficient is negative 0.6. And if I need to name this polynomial, it is a cubic polynomial because it has more than 3 terms. Please pause this video now and complete question 1 on your worksheet. The second thing we are going to do with polynomials is either add or subtract them. Adding and subtracting is simply combining like terms. So on letter A, looking for like terms, I want to make sure my polynomial is in standard form. So I will start with the terms that have the degree 4. That's the largest degree. When I add these, 1x to the 4th plus 2x to the 4th is 3x to the 4th. Next would come this 2x cubed. No like terms to put with that, so I'll just copy down the 2x cubed. And last, a positive 8 plus a negative 9 is negative 1. When you are subtracting, remember this minus sign changes the sign of every term behind it. So you could recopy the problem and distribute the negative. Or just remember you're subtracting. But I will copy the problem so that you can see. So negative 3x to the 4th minus times a minus is a positive 12x cubed. And minus times a minus is a positive x. Combining like terms. 9x to the 4th minus 3x to the 4th is 6x to the 4th. Negative 12x cubed, positive 12x cubed, those cancel. My next term would be my positive x squared, then my positive x, and last I have my negative 8. And there is the difference of those polynomials. Please pause the video and complete question 2 on your worksheet. The third thing we are going to do with these polynomials is graph them on our graphing calculator and identify the zeros. Make sure you have your graphing calculator available and ready to go. Bringing up my graphing calculator, I already have the first polynomial graphed. It was y equals negative 3x cubed minus 6. Looking at the graph of that polynomial, I can see that it has 1 0. Remember, zeros are solutions or where my polynomial crosses the x-axis. In this case, it crosses once. I need to be kind of careful to make sure that my polynomial doesn't come back at some point and cross again. But it looks to me, I could extend the window and check that out, but it looks to me like this one does only cross in one place, which means it has 1 real 0. Remember, we've calculated those zeros before. To do that, we push second, calculate. Number 2, we want to calculate the 0. Then my cursor needs to be left bound, left of what I want to find. Push enter. Move my cursor right of what I want to find. Push enter. And then remember it says, do you want me to guess? And I do. To be a 0, my y value should be 0. And my x value in this case is at about negative 1.26. So I will enter that information back on my worksheet. X is about negative 1.26. My second polynomial that I want to enter, let's go ahead and enter that one. Come back here, y equals, clear that one out. The second one was negative, not negative, just 0.25 x to the power of 4 minus 3x squared plus 10. When I graph this polynomial, I can see that it does not cross the x-axis at all, which means that it only has imaginary solutions. It has no real zeros. So I'll come back and note that on my worksheet. Please go ahead and complete the last question on your worksheet. Make sure you come back to class with all 3 questions answered and be prepared to discuss and explain your answers. Thanks for watching. I'll see you in class.